Okay guys, real quick, we're going to talk about a couple features of functions we want to look at some more. We've got our end behavior. End behavior is simply what's happening to the graph at the two ends. You've got the positive end up here and you got the negative end down here, or as x is going more and more to infinity. So that's what we filled in the blank here as what is happening to the behavior graph as x gets bigger and bigger and bigger and goes to infinity. What's happening to the graph, and as x goes lower and lower and lower and lower to negative infinity, what's happening to the graph. So you can look at this first one. Okay, as x gets bigger and bigger and bigger, goes to positive infinity. Okay, what's the y doing at that point? Well, you can see right here, as x goes to 1, y goes to something like a 2. As x goes to 2, y gets even bigger. As x goes to 3, y gets even way bigger. And it's pretty clear to see that as x continues to grow, y is also going to continue to grow. So we're going to say that y also goes to infinity. Now on the other side of that graph, we're going to look backwards. So as x goes to negative infinity, as x is getting to the left, to the left, to the left, as I get smaller, negative 2 comes down here, and negative 3, there's the arrow drawn, so it's going to be way down here. It's even lower. Negative 4 is going to be even lower. So what's happening is as x goes to negative infinity, the y is also going to negative infinity. Okay? Just the same thing on this next graph. Look at it the same way. Okay, as x is getting bigger and bigger and bigger, after right here, now initially it does go up, but from right here to the right, as x goes bigger, y gets smaller. As x gets bigger, y goes even smaller and even smaller. So as my x increases, y is decreasing to negative infinity. Alright, on the other side of the graph, as my, somewhere in this range, from here down to negative infinity, what's happening to the y's? Well, here it's a very large number, looks like maybe an 8, and then on negative 3 it goes down, and at negative 4 it's going to go down even more. So it's going down to negative infinity. Now notice that on this graph I was talking about f of x, and on this graph I was talking about y. Remember, they're the same thing. This last one, notice as all the way, starting way up here about 3.5, from here up it starts going up, 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 up. So the farther I go positive with x's, the y's are also going to go positive all the way to infinity. And over on this side, starting right about here, as the x's go lower and lower and lower, the y's get higher and higher and higher. So they're increasing all the way to positive infinity. Alright, take a moment to look at that. Alright, the next thing we talked about with the same graphs was even and odd behavior. So what we found out is it all has to do with the end behavior. So for an end behavior, if the end behaviors are different, we know that the function is going to be considered odd. Okay, so those are odd ones. And if the end behaviors are the same, we'll call them even. So basically we're using the information we had from the last graph anyways. On this first example, the end behaviors on two opposite directions, they're different, therefore this is odd. And this middle one, both of the ends are both facing in the same direction. They're both going down, so they're both the same, so that's even. And on the third one, the end behaviors are both facing up, so they're also even. Okay? We're not going to talk a lot about this details, but some extra information that'll come up later in our study of polynomials. We'll talk about how odd polynomials will always have an odd number of zeros, and even polynomials will always have an even number of zeros. Okay? And again, that's really right now doesn't make a whole lot of sense. We haven't talked about it much, but that is the case. Okay, and then the last thing to talk about is this is mislabeled. These should be This should have been odd and this should have been even. It was a typo. But we find out that the degree of these polynomials will also be even or odd. And the degree, if you remember, is the highest exponent in a problem. All right? Okay, we talk about a function either increasing or decreasing as we read the graph from left to right. So in this case, we're always going to read as x increases. So as x moves along from left to the right, what is this graph doing right now? Well, as x moves along, this graph is increasing. All right. As x moves along, this graph is increasing. Okay, and then from here down, as x moved from about right here to here, in this little chunk of space of the domain, the y's decreased. And then in this last chunk of space, from here on to infinity, the y's are increasing. Alright, so what we're trying to do there is just kind of pinpoint little domain sections of where the function increases and decreases. And that's really what we're looking at.